Hey, g'day, it's Preso here. Thanks for joining me after breakfast. And in this series of videos, I want to do metal finishing processes in the home shop. Now, often in my videos, I'll do a process like zinc plating or powder coating or anodizing, and I'll show that as part of an overall build of another project. And as such, you tend to gloss over it a bit, not go into too much detail. So in this series of videos, I want to break it down and show you how I do it in the home shop. Now, that's not to say that it's the ideal way of doing it, and people who carry out these manufacturing and finishing process commercially would obviously work to a much higher standard than what I can in the home shop. Now, I want to be clear about it. There is some cost involved if you want to get it into any of these processes. I don't believe it's worth using inferior techniques or inferior materials to get a result. So in this first video, I'm going to work on this aluminium casting. Now, this is a table that I made for a metal cutting bandsaw, and underneath you can see that it is just cast, and I think that could be tidied up a lot by using a process called powder coating. So in this video, that's what I'm going to concentrate on, and I'll do this part and this part, which is a bracket which goes on top of the bandsaw frame. I'll put a card up if you want to go back and have a look at the playlist that this is part of. So I'm calling this series of videos Metal Finishing with Mark, and this one is Powder Coating 101. Okay, so why powder coating in the home shop? What are the advantages? Well, if we compare it directly with, say, liquid paint, powder coating is more resistant to chipping, scratching, it's wear resistant and fade resistant. It's also chemical and oil resistant, so if you're using it to paint parts that are used in machinery, it stands up well to that sort of environment. There are no volatile organic compounds released during the powder coating process. Now, you would know if you're using liquid paints that the solvents and the bases for those paints often contain toxic chemicals. Many of those are cancer causing, and if you read the warning labels on those cans, it'll tell you that you need to wear a respirator or a pressurized suit just to protect yourself from those organic compounds. There's also very little waste. So during the powder coating process, we're putting the paint onto the part using an electrostatic process. That means that most of the powder will stick to the part. Some bypasses that and ends up on the floor or as waste, but probably not as much as you would get with, say, an ordinary spray painted or a liquid paint. And also it means at the end of the day, you don't have lots of leftover solvents to get rid of. So if you're cleaning a spray gun or a paintbrush, you know how much solvent you have to use to do that. That's usually a waste product and you need to get rid of it, and it's flammable. So it can be hazardous to have that stuff around the home shop. Okay, in order to get started with powder coating at home, you're going to need some gear, and none of this stuff is necessarily cheap either. Now, I live in Australia, and I found one of these DIY powder coating kits online from a company called Eastwood. And at the time when I purchased it, our Australian dollar was worth about 75 US cents. And by the time I got it shipped over here to Australia, it was a fairly expensive piece of gear. However, I don't ever regret spending the money on this kit. It's given me the opportunity to make parts and finish parts that look what I call like a bought one, like something that you'd find commercially available. And when you buy the Eastwood kit, you get the power supply. It's a high voltage power supply. You get the powder coating gun. You get a small disposable paper filter, which goes on the air supply. And because I live in Australia, I had to buy a 110 volt transformer. So this takes my 240 volt shot power and turns it into 110 volt, which this unit requires. Now, this DIY powder coating kit also came with a selection of powder coat powders, and I think there was like half a dozen from what I recall. You will also need a compressor, so you'll need some sort of shop air supply to be able to supply air to this gun. The gun itself only requires a very low pressure, something like 15 psi. The whole kit that you can see here, I just hang it on the wall when I'm not using it. So it sits up out of the way. I can get it down in seconds, have it all set up, and I keep all my powders in just a plastic tub. I can set up to powder coat an item in about 5 minutes. It takes about 15 minutes in the oven, And that's it, it's basically done. Okay, a few other things that you will find useful when you're doing powder coating at home, but these are not absolutely essential. Get yourself a spoon for transferring the powder from containers that you buy it into your powder coating gun. Next thing, when I bought the Eastwood kit, it came with a series of these silicone plugs. Now these are handy for filling up threaded holes or areas where you don't want the powder to go. You can buy these cheaply on eBay as well, and AliExpress, places like that. The other thing that came in the Eastwood kit was this heat-resistant, I think it's a fiberglass self-adhesive tape, and this is good for masking off areas, once again, where you don't want the powder coat to go. Now this tape is quite narrow and it's not terribly flexible if you want to go around corners, but it does work and it does hold on very well in the oven. You can also use this capped on tape, and you can buy this in various widths and so on. The other thing that came in the Eastwood kit was this stainless steel lock wire. This is just handy for hanging parts in the oven, so you can put it through an existing hole, form it into a hook and hang it in the oven. And these, if you make these hooks, you can reuse them. Now it doesn't have to be stainless steel wire, you can use any sort of wire. Copper wire works quite well. You also need to be able to form an electrical connection between the earth wire on the powder coating gun and the part. So you do need to use a metallic wire, something that will pass current, so you can't use fishing line or anything like that. So let's talk about powders, because that's probably the biggest barrier if you're getting into this for the first time. Now, of course, if you buy the Eastwood kit, it will come with a selection of colours already in the kit. I think you get between 4 and 6. And these are 8-ounce bottles. And the other option is to go for someone like Amazon or eBay. Now, I just checked this morning, you can still buy powders from Amazon, and they will ship to Australia. Of course, you live in the US, you're fine. They look after you. But elsewhere in the world could be a bit difficult. eBay is another source. I checked today, and on the eBay Australia website you can get powders. Most of them are Eastwood powders, and the cost is that's reasonably high, and you've got to factor in shipping as well. Now there is another option if you live in Australia. This company here called Gilking School Supplies normally sell to education departments, but I checked with them this morning and they said they're happy to sell over the counter or retail. And they have a website. I'll put the contact details below and in the description as well. And the good thing is that they sell by the kilo, and it's reasonably priced, about $40 per kilo depending on the colour that you get. Now they do have a limited range of colours, about 10 including clear. They recently expanded their range to include a sparkle silver or a metallic silver and a mica black. And I'm going to try both of those out on this little project I'm working on at present. So there are options there, but just take my advice, don't ring up a company like Dulux and ask them if you can buy powder, because they'll only want to sell to you in huge lots. All right? If you ask for a kilo, they'll just laugh at you and show you the door. So that's my recommendation. Look at eBay, look at Eastwood Direct if you can. If you live in Australia, try Gilking's. Amazon is also a good source. Now the other piece of gear that you're going to need is an oven, and a lot of first timers who get involved with this will go and buy a cheap toaster oven or scrounge a cheap toaster oven. In fact, that's what I did when I first got started. The problem with the toaster oven though is that you soon realise that it limits the size of parts that you can do. So what I did was I went to my local electrical repairman and I asked him if he had an oven sitting out the back that they were going to toss out. He had this one here. I got it for nothing. It still worked. I think the only thing that was wrong with it was that the controls, the knobs and so on, were broken and missing. So I brought it home, I've modified it so it takes a PID controller, which allows me to set a fairly accurate temperature, and I retained the original timer and the original on-off switch, but I've made a new front panel for that and fitted new knobs to it. I also fitted this little ammeter here just so I keep an eye on the current, because I'm running this from basically a standard shop power supply, and I'll turn it on in a minute. You can see how much current it's drawing. So I usually just leave this thing turned on here with this control, but as soon as I turn the timer, the PID controller will power up and that will start to heat the oven. So we'll do that. And keep an eye on the ammeter. And you see it goes up to around about 13 amps. Now I'm running this from a standard 10 amp power point in my shop. Now I know there's people out there who are cringing right now, but guess what? It works, and I don't trip the circuit breaker. Now admittedly, I'm not doing anything else in the shop usually at the same time. Probably if I was running a welder or something like that, yeah, it could be a problem. But up until now, I've never had a problem running this on a 10 amp power point. You'll disagree with me, I'm sure, but I'm just telling you what works. Okay, these PID controllers can be bought on eBay dirt cheap. They come with a thermocouple that fits inside the oven. I just sort of poked it through from the back, and it allows you to set the oven temperature. Now, most powders that you use in the home shop situation require baking at around about 200 degrees C. I'll put the Fahrenheit equivalent down below. And the baking time is normally 10 to 15 minutes. Now, you don't need to fit this PID controller or the ammeter. Now, if you just had an ordinary domestic oven, you could use the thermostat on the oven and get close enough to 200 degrees. If you're really worried about it, you could put one of those barbecue thermometers inside the oven and check the temperature against the thermostat to see how much area you have. Just one other consideration: if you're going to use a domestic oven and you have the original controls on it, make sure you use it with the fan forced off. If you open the door and there's air blowing through from the back of the oven cavity, when you place your part on the rack or you hang it, air can dislodge that powder. It's only very lightly adhered when you put it in the oven, and you really don't want to have air blowing through from the back of the oven. Let's talk about preparation of your material for powder coating. Now, I know I said I was only going to do 2 castings here, but I've thrown a couple of extra parts in just to show you how it behaves on different substrates. So this is some sort of a mystery metal. I'm not quite sure what it is. Probably some sort of zinc-based die casting, and I've got 3 steel parts here. Now, the best way of preparing your material is to sandblast or bead blast. What that does is strip off the oxide layer on the surface, and it also provides a mechanical key. And it doesn't matter whether you're using liquid paint or powder paint, that's your best chance of getting good adhesion between the metal and whatever coating you put on it. Now, if you can't sandblast or bead blast, the next best option is to wire brush it and then use some sort of a solvent material on the surface. And I'll show you how I'm going to do that shortly. But also we need to talk about castings, and the problem we have with those is that they will always have some surface porosity. If that porous surface has been in contact with things like oils and greases and waxes, it gets trapped in that porous layer. When you put the powder coat onto the part and put it in the oven, those organic compounds can bake out of the surface and come up through the layer of liquefying powder and leave little pimples and marks in the surface. So the best way of dealing with that is to pre-bake your components in the oven. So get the oven hot, 200 degrees C, put the parts in the oven for about 15-20 minutes, and that way anything that's on the surface will tend to bake out and evaporate before you put your powder coat on there. So that's what I'll do with these 3 castings. I'm going to put those in the oven now. Okay, I'll leave them for about 20 minutes. Alright, the timer's gone off on the oven, so I'm just going to let them cool down inside the oven, and then we're going to get them cleaned. Alright, this is cooled down from the oven now, so I'll just demonstrate on this one part because essentially they're all the same. So the next step is preparation for actually applying the powder coat to this part. And to do that, we need to make sure the surface is chemically clean. Now, a lot of information you read will tell you that you can use acetone or isopropyl alcohol and basically swab down the surface to remove any impurities. But I believe and I've read that you can contaminate the surface further by just simply moving the contaminants around on the surface. So this is the tip that I got from the legendary Dan Gelbart, who does an excellent video on powder coating. And his recommendation is just common or garden variety Ajax. And this is a bit faded from sitting up on the windowsill for so long. Now, there are a number of active ingredients in Ajax. The one that I can pronounce is sodium carbonate, which is basically an alkaline solution or an alkaline powder, and the other one I'll put on the screen below and you try and read it. But both of these materials do more than just removing grease and oil from the surface. I understand that there is a process that goes on which chemically activates the surface of whatever it is you're cleaning. And by that I mean that it becomes more receptive to molecular adhesion. Now with aluminium or aluminium alloys, you need to work fairly quickly once you've done this process. So, within an hour or two you need to get it powder coated. So all we're going to do here is just scrub this all over with an old toothbrush, a bit of water, dry it off, and then we're ready for the next step. Now, you can do that thing called a water break test. After you've done this cleaning process, just run water over the part. If it washes off or runs off without forming beads, then you know you've got it pretty right. But clearly, anything on that surface which prevents molecular adhesion of the powder is going to weaken the bond. Alright, if I bring you in close, you can see that this is what we're after here. So the water is just sheeting off that surface without breaking. A little tiny bit at that corner there, but over here you can see it's much more pronounced. So the water is sort of pulling back from that corner or that edge, and here it's particularly bad. So obviously there's oil and contaminants inside those threaded holes, which I'm not getting to, and it's just sort of spreading out across the surface. But the rest of it's looking pretty good. So that just tells you that you need to work a bit more on those two areas. So let's get them done. And this would be the same whether you're using a liquid paint or conventional paint, or if you're going to do something like anodizing or plating. It's the same process. And the good thing is that Ajax is cheap. It keeps indefinitely, it's got no shelf life. So it's the way to go. Alright, now we're looking much better. So we're going to blow this down with compressed air and just let it dry. You can hang it to dry, you can put it back in an oven or use a hairdryer or something like that. Well, I have that part in the oven just drying off after I blew it off with compressed air, but let's talk about the gun setup itself. Now, I've made this little unit here which normally hangs on the wall on a French cleat system, and it's got the control unit underneath here. It has just a simple bracket for holding the gun, and I've just put a way of holding this little switch in place, which we'll talk about shortly. Now the gun itself is very, very simple. Consists basically of just an air duster gun or an air blow gun. You've probably got one of these lying around your shop already. There's the paper filter here to make sure that your air supply is dry, and there's a cup that you can fill with the powder. Now you can get these as spare cups from Eastwood, and you can just leave your powders in these permanently if you want to, and just screw them on and off the gun as you go. Also inside there is two tubes. Now this tube here delivers the pressure from the inlet to the filter and goes right to the bottom of that tube, and as it exits that tube it just stirs up the dust in the bottom of the cup and turns it into a sort of a suspended powder. This shorter tube here is the pickup tube that sucks the dust up from that inside of the cup, delivers it out through this longer tube and past the diffuser. There's also a wire running through the center of that tube which delivers the electrostatic charge to the powder as it comes out of the gun. Now when you get your gun from Eastwood, it will come with a diffuser that looks like that. Now I used that for a long time before I realised it's not the right shape for most of the parts that I do. So the best thing to do is take that off and don't throw it away. It's actually useful for doing large flat panels. If you're doing smaller, more detailed things, this is the better shape to use. Now, this is just made from acetal or acetal, and it's about 11 millimeters diameter on the tip. It's maybe 8 millimeters at the small end, and about, I guess about 16 millimeters long. And it's just a press fit on that wire. And this gives you a more tighter, more concentrated flow of powder onto a part. if you try and do small parts with that other diffuser, you'll end up wasting a lot of powder. It just goes everywhere except on the part. So get yourself one of these, or make yourself one of these. They're way better. Now the powder I'm using today is just a silver fleck. This is one that I got from Gilking's, and I should add that Gilking's aren't sponsoring me in any way whatsoever. That never happens to me. And all we're going to do here is just take some out of the big container and put it in the cup. Okay, this is where your kitchen spoon comes in handy, and the amount that you put in the bottom of this cup is not critical. I'm going to just put about 3 spoonfuls in there. And remember, all you're doing is you're allowing that air supply going to the bottom of the cup to stir this up and make it into a suspended dust inside the cup. If you put too much in there, that action is diminished and you don't get a steady supply coming out of the gun. So I'm guessing I've got about that much in the bottom of the cup, and that's plenty. Right, power's on. Remember, these are 110 volts, these control units here. And if you're running off 240, you're going to need a step-down transformer. Okay, air supply goes on, and it's around about 15 to 20 psi. The amount of air that you use can be regulated a little bit by that trigger there. So you can see there's our powder. So it's just like a billowing sort of soft cloud. That's the best way to describe it. Now, the other thing you need is this switch. Now, puzzled me for a while why you needed this. I couldn't figure out why you just didn't have it on permanently and just dust the part and you're done. Thing is though, that when you got this hand on that dead man switch, it means that you can't accidentally discharge this high voltage electricity into your other hand. So it sort of prevents you from hanging onto a part and trying to dust the powder onto it at the same time. So when you go to apply the powder, you just depress the switch. There's an indicator light on the top of this panel here that tells you that everything's on and functioning. So I don't know if you can see that. There it is there. Obviously if you don't see that, something's wrong. And pretty much we're ready to go. So let's hang the part and have a look. Okay, this is the other thing you'll need, is some sort of way of hanging your part in your shop. I've got a piece of wire which just hangs from one of the ceiling joists in my garage, and it's all steel construction, so this gives me a good earth. This clip and wire is the earth from the control unit, and that just simply earths out your part while you're adding the powder. Now, the way you do this is completely up to you. You might have a different area in your workspace where you can do this. For me, this works fine. I'm just doing it against this garage door, so when I'm done I can open the door and blow all the excess dust out. So really the only requirement here is that you try to get the powder all over the part. Now, it's electrostatic, so it will be attracted to the part and it will tend to bend around the corners. Alright, now that's taking a while actually to get going. I've noticed this with certain powders that initially it doesn't stick, it doesn't want to adhere to the part, and once you get a layer on there, that seems to attract more powder on top of it. So if you don't see it sticking straight away, just persevere a bit, add a bit more, and you'll find that eventually it starts to build up. So let's just keep going here. Alright, so that's pretty much coated that surface there. I'm just going to turn this around, we'll have a go at the other side. Right, I'm just trying to give you a better view there. So even though I sprayed the other side first, a lot of that powder is sort of bent around to the back of the part and it's already starting to coat the rear side. But just the same, you need to walk all the way around or turn the part. Make sure you get all of the surfaces done. In this case, not quite so easy to see how much I'm putting on because it's a silver part. We've got sort of a silvery grey powder. But essentially, you know, you really can't put it on too thick. It's not like paint where you can get a run in it. I must say I've never used this powder before, and some go on much easier than this one. Don't know why. Alright, that's looking pretty good. So I think we're ready for the oven. Okay, so there it is. Let's get it in the oven. Just one thing though, if you accidentally bump this at this point, you're going to remove the powder. If you drop it on the floor, it's all going to fall off. If anything goes wrong, you just blow the whole lot off with compressed air and start again. So don't panic too much if it sort of gets a bit messed up getting it in the oven, but you do have to be careful. Okay, so I'm just hanging that from the rack that was already in the oven. Just got to be a little bit careful, you don't touch anything when you get it in there. So I'm going to leave this now for about 10 minutes for that powder to liquefy, and then it has to bake at that temperature, 200 degrees C, for another 10 minutes. We're at about 10 minutes now and that surface is starting to liquefy. It should look wet and glossy, and now you're going to wait another 10 minutes after that for that to fully cure. There's a little miter fence going in. You can cycle the parts while one's curing, put a new one in, that's not a problem. Fun fact though, a day after I sandblasted that part, a viewer got in touch with me and said he had a vapor honing set up and he'd offered to vapor hone that for me. And there was I with it already done, so too bad. I would have loved to have seen that process done on a part like that to see what sort of effect it gives you. Okay, that one's done, so it's going to let it cool. The other one's not far off. Well, here are those parts now. They cool down. I know it looks grey, but it's actually a very subtle silver, I guess. And for what I'm doing, this is fine. I mean, they're meant to be aluminium parts, and it sort of looks the part, and it's now protected. It won't oxidize any further. And they got that nice sort of semi-gloss finish to them as well. So I'll put them aside. Now this is the next part that I need to do. This is the table, and I want all of the underside of this powder coated and the edges, but I don't want to do the top. So it always presents a bit of a challenge. You have to think about how you're going to mask off the areas where you don't want the powder to go, and also how you're going to earth this part so that we can form the electrostatic charge. So what I'll do is I'll turn this over. I'm going to mask it off with just ordinary aluminium foil and some of this high temperature tape, and then I've got a 6mm threaded hole here, and I can attach a metal thread screw into one of those holes and put my earth clip on that. I'm just going to fold this foil, leaving a little bit of a margin so I can attach the tape. Well, that's pretty well sealed on that side. There is a bit of a gap underneath the tape, just where that slot is, but I'm hoping to demonstrate a rather peculiar property of these high voltage electrostatic guns, and that is an effect called the Faraday Effect. And typically what it means is that the powder won't want to go into narrow grooves or countersunk holes or areas where you have protruding material either side, so for example gaps and slots. So if you go to buy one of these guns, there are two types. One's called a single voltage, the other is a dual voltage gun. The dual voltage type allows you to turn the voltage down, and that helps you to get the powder into areas like this. So mine's only a single voltage gun, so I've just got to learn to deal with that. Okay, so let's get our screw in here now. This has already been cleaned. It's been in the oven to bake prior to putting the powder on. So we can clip our earth lead onto there, and you may actually notice when I'm putting the powder on here that the powder won't want to go all around that threaded hole. Let's see. Okay, we're all earthed and ready to go, so let's give this a try. got a nice uniform coating on that, so yeah, let's cook. I was going to change out to a different colour here, so I thought I'd show you what's involved in that, and this to me is a real advantage of this powder coating process. The cleanup is incredibly quick, so all the excess powder that's in the cup goes back into your big container. Okay, air gun, and just simply blow off all of the existing dust on the siphon tube inside the cap, inside the main body of the gun, and that's it. That's the gun. Now, if you're using the same cup over and over again on your gun, you just do the same with that, just blow out the excess dust. Okay, that's done, and we can now change to a different colour. I've just changed over a different powder. I've got a black mica in the gun, and I've got to do a few steel parts. Now, I read on a forum a while ago, somebody was talking about, is it possible to patch a casting, repair a blowhole or a crack using auto body filler and then powder coat over it. And the consensus was that no, you can't do it because it's got to be electrically conductive. Well, guess what? You can do it. Here's a piece of MDF, just for fun. Let's coat this and then bake it in the oven and see what happens. All right, here we go. Now, you got to remember, this is an electrostatic process, not an electrical process. So you remember that old experiment you did with a comb and a piece of paper, and you put a static charge in it, it picked up the paper? Well, none of that stuff is conductive, and yet it works. So you can see how easily that coats, in fact much easier than metal. And you will also notice around the wire, this is the Faraday effect that I was telling you about. So because of the proximity of the earth wire and the small space around that, the powder doesn't want to go there. And that's where having the dual voltage gun makes a big difference. Now in this case it doesn't really bother me, but if it was that was an important part, I'd probably need to hang it in a different way just to avoid that problem. Let's turn around and do the back. And you can see there how the powder started to come around the back. It's already done the edges. And I'll just finish this up and I'll go and put it in the oven. Now, why would you want to powder coat wood? Well, you don't. I'm just demonstrating that you can powder coat non-metallic items. Okay, I'll go and bang that in the oven and we'll check it out. I just cleaned up, all this is done, so there's a little unit ready to go back on the wall. If you can find a little coat hook like that, just takes care of all the wires and makes it tidy. Let's put it back. Done. Now you may be wondering, you know, do I really need a dust extractor or a fume hood or somewhere to work to contain all that powder? Yeah, it'd be lovely if you had the room for it, but I don't. All I do at the end of the day is just blow this out the door. The workmate is where I was doing the table or the bandsaw, and the area underneath that was where I was doing all the rest of the parts. And you can see that there is some powder there, but this is how easy it is to get rid of it. Job done. So you can see the top of the table is still clean. Didn't really get any powder at all in these ends, maybe a tiny bit. None has made it up into the rebate where the throat plate will go. So the back looks good. So here are the black parts I did with the black mica. Once again, it's more of a satin finish than a gloss. But I thought I'd try it out just to report back to the people who gave it to me, which was the school where I used to work. Right, here's the piece of MDF that we did. And it'd be interesting to see what that looks like with a clear powder coat over the top. Alrighty, that's it. I'm going to leave the video here. Just one thing before I go. If you're looking at the colours that I've used on these parts, well, look, they're not brilliant, but there are much, much better ones out there. In fact, the range of colours and finishes you can get in powder coat are as good as any liquid paint you'll ever see. So we're talking about satin finishes, gloss finishes, you can talk about wrinkle finishes, hammer tones, there are transparent colours like candy colours, metallics, you name it, it's there. And some of them are truly impressive when you see them done by professionals. So like I say, this is just a representative sample of what I have. I've got much better colours that I use on truly decorative work. Now, speaking of decorative, in the next video, when we come back, we're going to have a go at a process called engine turning or dueling. Now, if you think about engine turning, think of that famous aircraft, the Spirit of St. Louis, or Spirit of St. Louis, or, I don't know, that Lindbergh aircraft, and you get the idea. And we'll do this just as a decorative finish on this, and yeah, it's going to be fun. So join me for that, and thanks for watching. Oh, and keep the comments coming in. I love reading those. Well, there's another one. It's just a bandsaw table. Paint it with a rattle can and be done with it. You suck. Unsubscribe. I bet this old Tony doesn't have to put up with this.